Hello everyone. In this demo I would like to share some of the remote control approaches I found that apply to the Play 700. And the main goal for me was to compare and contrast RC control approaches that's suitable for each tool, whether you use Task or Scratch 2. So we'll illustrate the two-part. First case is only one remote control button are being used at a time. For example, up only, down only, left only, or right only. And in the second case, you may have multiple buttons can be used at any one time. So maybe you have go forward and then also you push R. Okay. Alright. So the first cut to task edge is a simple one, you know. Wait until the data arrive, pick it up, found out it's up button, you forward, and then you have an if-else-if structure because it's only one possible alternative among many. So good old if-else-if structure, up, down, left, right, that's it. And let's see how does it behave. So let's bring up the task code. There we go, got the actual task code. Right now you see I'm using BT210, so it's pretty far away from my my PC itself. Make sure I gotta download it. I forgot to connect to it, so give me a sec. Okay, let's see if we can download. Connected. And downloaded. Okay. Now let's see if we can play. Start. Okay. So up. Pretty much normal, nothing special there. Of course, if I push both keys at the same time, up and right, which is setting at 9, my program I didn't write my program to handle that. So you see the robot just sit there, couldn't do anything. So let's stop that. And it's disconnected, good. So I'm gonna close task. So next we're gonna bring up the Scratch 2 code, trying to do this basic RC, the same thing here. And so remember the computer's on. Let me connect. Let's see. Okay, I'm connected to it, and I made two Scratch 2 version. Both of them use the event-driven programming procedures that they have. I go into detail later, but roughly visually you can see this is one section for the up arrow, this one for the left arrow, this for the right arrow, this is for the down arrow. So let's bring the actual code up. It is so you can see a little bit more detail. For now, let's hit. So essentially, whenever the up arrow is pushed, set port 1 500, port 2 to 500 essentially, and then basically it has a wait here. So let's see, let's bring it up so we can record nicely. Yeah, we go. So wait until not the up arrow key pressed. So in English, essentially, whenever I push the up arrow key, it turn on the motor 1, port 1 and port 2, make the robot go forward. And then as long as I press the key, it just stay here essentially. As soon as I release that, it turn all the power off. Similarly, you see I can do the same thing for left arrow. Same thing for right arrow here. And then same thing for down arrow essentially. Okay. So let me zoom out. So in theory now it should work. because in interpreting mode, and let me go and check to see if my bot is still on. So hang on please. I just went over there and checked my bot is still on, and my plus scratch still working. So scratch 2 is being connected now. All I have to do is just push the up arrow key. Here we go. See, it's working. And you can see that if I push up, this area I highlight on. Going back now, and a left, and a right. If you look carefully, you're kind of far away. But if you push up the first time, you're gonna jerk, and then go straight. You jerk to the left a little bit and go straight, and down. Oh, a little bit better. Of course, I'm trying to push both of them now. I look like right arrow is in control. I release the right arrow, but they're still stuck there. Okay, that was fun. Okay, so I made a different version. This one here, I up and arrow is the code is more reduced, and I push the turn off power into a different event-driven block. So let's have a look. Here we go. So let's look at the code with more detail. So you see right now, when up arrow, I set the power on just to go on. Left, turn left, right, turn right, down, turn right. But I also add a piece of code that only will be triggered when I click on the flag, and it's an endless loop. And let's see, you have to reduce a little bit, but it's a big, basically. In English, it say that if it found out that no up, down arrow key is pushed, and well, none of the up, down, left, right arrow key push, and boom, it turned the power off. Okay, so it's easier to explain in English. I'm trying to see through the code. All right. And so the program should be, the new SB2 is running now. So this is interesting. So if I have to be careful, if I start up arrow or any of the arrow key first, it's gonna go here. That means the bot keep on running right away, it won't stop. Okay, I'm gonna push the down button right now. You're gonna see it start going, and it won't stop until I flash this one. Here we go. So when that code is going, and then that part of the event is taken care of, let's bring it back here. Alright. Here we go. Come back. Come back. Come back to me. You see, because of the delay generated the communication, port 1 always turn on before port 2. So you see, it didn't go straight at the beginning. But for long term, it's okay. But as a start, it's having problems. Especially going forward, it's very obvious. Okay, that is enough. So we can stop. Okay, what's this next? what is next is first we have a scratch 2 that for multiple buttons, shall we say. Okay, let's have a look at the actual code. Oops, sorry, hang on. Here we go. So you can see. So in this one here, it just have everything inside a big endless loop. When you click that is, and essentially, let me zoom in. So it have a bunch of parallel if, shall we say. So if up arrow, power on going forward, if down going backward, right go right, left go left, and have a fifth one if none of the key are pressed and power off. So basically that's the piece of code. So I'm turn it on to run it. So it's running now. And so you see if I'm pushing forward key, it go forward, backward, go backward. Let me get it ready. Come back out here again. Okay. Yeah, let's go back here into the screen. So I'm gonna push forward key, and then when it go, I'm gonna hang a right also. So essentially, this one here you can see that I'm allowed to go water move, but it's combination. So basically, go forward a little bit and go backward a little bit. Go back. Okay. Uh-oh, it got stuck somehow. There we go. So I'm going forward and hang a left at the same time. So left, forward a bit. So it turned out it can handle multiple keystroke. And it does backward too, but it's not very well, just because of the geometry. Okay, so essentially this piece of code in Scratch 2 will provide you to essentially, as a side benefit, is handle multiple keyboard. How does it look on the Scratch, on the task side? To do the same thing, and it turned out to be on the task side to do the same thing. It was kind of complicated, because first I try out on the task side. I thought, oh, all I have to do is just let's bring it Scratch back. All I have to do is just push this big endless loop with 5 if in there, back to it, and it should do it, right? So I create this one. That's a task, and let me bring it in. So 3A, where are you? Let's see. Here we go, coming up. So this one is a task program. All it does is, I thought I could just translate the Scratch code from over here into the task code. So I have a big endless loop. I pick up the button and I say, okay, if you push anything, you stop. Basically, I have a bunch of parallel if in there. And let me make sure I reset everything. Okay, remember we've been playing with this one, so I have to disconnect from here and go to task. So I freed up my COM port. Yeah, you can see it's blinking now, so halfway freed up. So I'm gonna download. Good, it's connecting, downloading. Okay, so before I play with this one though, I need to go over and restart it on the bot. So give me a sec. Okay, I'm back. So let's see if we can work it up like a task code. Start connecting. Alright, so now I'm using forward key. Okay, I'm gonna do it, gonna push up for key forward and put right also. In theory, it should go forward a little bit, right a little bit, forward, right a little bit, just like in the Scratch 2 code. Let's see. It did not work. You see here? Let me go back. So in the screen, so you can watch the little guy and see. Okay, I'm going forward now for a little bit. Now I'm adding R, but it's still going straight. It doesn't do any change. Okay, so I first learned is Scratch code is a different solution, and whatever's going on in here, you cannot exactly change to a task code. Basically, do a direct translation from whatever you know from your own programming practice and expect it the same. It didn't work, so I had to took me some time, but then I finally figured out how to make it work. Was essentially first, when you take the data in, you have to filter with up, down, left, right. So the parameter up button, down button, left button, right button, essentially just like flags. Okay, they will be non-zero, mean that that up button was pushed, for example. So any of these up, down, left, right button, if they're non-zero, like I show here on 716, if non-zero, that means you want it to go forward, and so I call forward. Also, I found out I had to put in a time delay of about 250 milliseconds for everything to work properly. Okay, so this is the actual code, and I need to go over there and turn the bot back on and off again. Okay, here I'm back again. Now let's see if we can download this new piece of code in there. Okay, download, connecting. Okay, download it, and turn this alpha off. So I'm gonna pause again. Give me a few minutes. So make sure everything is on. So let's play now. Let's start. Connected. So now I'm going forward. Going backward is normal. I'm gonna go forward, and then I'm gonna push right also. It's struggling a little bit, but it's doing forward and right a little bit there. You can see. Let's see. Forward. Kind of poorly there, you see. Okay, let's try it again. I'm gonna go forward and then gonna go left at the same time. So you can see I did that a different curve. Okay. So very interestingly, I didn't plan it, but I found out that each tool task Scratch 2 require different problem solving approach, and the code that you obtain from them are not directly translatable to each other at all. So each of them have different capability and feature, and problem solving approach had to be different from each of them. That was interesting. I was very pleased to learn that. So later.